Hello. Today we're gonna discuss about correlation between pulse and calories. Let's start also the practicum of that one, and let's start. Yes, I'm starting on that, to study and to research some of the most important research about the pulses and calories, how that happening right now. And so far, now I'm started. My pulse at this moment is 88, and my speed is just one starting, just beginning. And so far, I spend calories just 1 calorie. So this is the beginning, starting at the slow motion, very much slow motion. And actually, there is a debate that, what's the correlation between the pulse and the calories? And at the study of the higher and credible source indicate that, the higher the pulse rate, the calories are burned in a higher amount. But that's the statistics really, because as the heartbeat goes higher, like a pulse is higher, they start working like pumping, and activities are drawn highly, and then calories are burned highly. That's the general principle. So in that case, starting and see today what happening actually, and how much calories are burned in what pulses, and gonna be explained, and that principle is applied today. And now my speed, I'm a little bit increasing, and I'm in 2 now, speed 2, and calories. Generally, calories are measured in kilocalories, the highest 1,000 calories, and they start from 1 calories, and kilocalories. So that is the food we eat, that we count as calorie, and then after that burning turns into energy actually. And when we do exercise also, it's called firing the calories. That means the input and output system in our body, as we in or feed the food, that turns into calories. And if we burn and utilize, that's called energy, that we do activities and all. And if we do exercise and fire out, that's the firing the calories. Now I am not utilizing actually the energy, I'm firing out the calories. So in that case, how high the calories I fire, and what's the correlation with the pulses? So the pulses, generally average pulse is 72 beats per minute, and the general calories, if we count for the healthy people correctly, the highly credible source indicate that that's the 60 to 100 per minute. And as we count that pulse, for the swift and quick purpose, we see that 15 seconds and count the beat, multiply by 4, or 30 seconds if you have a little bit more time, or 30 seconds and multiply by 2. That beats, that comes the pulse, actual pulse, what's going on. However, in activities, that goes into oscillations and fluctuations. So these fluctuations depends on how high and how strong, how high activities are involved. Now I'm in speed 2, my pulse is 75, and also my calories I'm gonna study as soon as possible when the data arrives. And let me see, yes, I spent just 17. So this condition going on right now. And now my speed, I'm going to increase 1 high. Let's go to my speed 3. Yes, now my speed going 3. My motions are a little bit increased. And I start burning calories and a little higher in the speedway. So my calorie now already burned 19 calories, and now my pulse, let me see, and I'm indicate a 154. No, so 154 is higher, pulses. Now, higher fluctuations going on. Now decrease 120 fluctuations. So this is like oscillations, like the higher level of fluctuations, the pulses, so the pulse, as the pulses fluctuate, and then we can calculate its activities, and in speed of 3 is going on. So this this 3 almost normal, and I'm planning to go still higher than that. Let's go about now. Let me little bit explain. 61 is my pulse right now, which is just normal, which is normalized. The speed stability seen, and then fluctuated, and now my pulse is 63, and then now my calories so far I spent is 104 already. I spent the calories at the time last in 6 minutes. Okay, so that's the wrong calculations. That was the pulse. Now actually so 29 calories I spent. Sorry for that. Now let's go to higher level of speed now. 4, little bit 4, yes. In 4, I start running also. And let's see what's the correlations coming with the pulse and the calories. 167, 130, yes, calories going to 32. Yes. Now as the speed I increase in level 4, and it's little fluctuating. Yes, 123 pulse. As the principle is that as the higher engaged activities goes, the pulses rises, and also calories are born. General principles, the highly credible source indicate that types of statistics. And I'm in 4 now. My speed going on. And in my speed, there's a 4 in 2.5 incline and 8 feet according to, and then my time lasts about 8 minutes and distance 0.325. And in these conditions, I have my pulse is 105 going on and fluctuating. Now decreased about 98 and 97, still decreasing because. And then my calories I burned so far 46 yet. Now I'm gonna plan again. Isn't 4? I'm going to do 5 now. My speed, one high speed, 5. My calories I so far. Now calculating the pulses. Let's go. Going with my pulse a little higher, 49. Pulse. Oh, wow. 49. I'm surprised. The activity is higher, the pulse is indicating lower intensity. 53. 54. Now calories show 58 calories. I spent so far 50 it's been a fire 59 60 calories. Yes. And again I'm gonna start calculating the pulses. How much the pulse? Here's yes, I'm 53. Wow, is my speed increase? The pulse is decreased. Wow, that's the principle against the principle or the activities increase and pulses rise. Now I see just opposite of that one. The correlation fluctuated down as my speed increased, my pulse is down. Now I spend the calories higher, but calories higher. That's the one principle. One side principle is correct as the activity is higher. And now correct. Now 145, 159 pulse. Now both principles correct. As the pulses goes high, and the calories are burning higher. As activity is higher, pulses are higher, and calories are higher. That principle is exactly correct now. And my calorie I spent is 77 now. And let's see the pulse, what's going on now. Is my speed in 5 and 106, and yes, correct. That principle is not correct. If pulse is higher, and the calories are higher, the activity is higher. The higher equals higher, lower equals lower. That principle is applied here rightly. My pulse is 169, and now 163. My pulse, yes, the activity is higher, and the pulse is higher. And the calories are born higher. Statistical born and 160, 59, 86, 87 calories I spent so far. And as the activity is higher, pulse is higher. It is true now. And yes, higher pulse is now coming to the 63. The pulse decrease down. The calories going high. Still, I spend calories 90. As the activities are higher, calories burn higher, and pulses are higher. That's the principle. And what is applied, not applied. Statistically and literally investigating with the matter now. Now is the statistic is at the beginning of the speed, the higher activities goes higher fluctuations and then comes down in normal. Normal and activity is still the same, but the normal comes normal. That's the principle now I established today. Is the one is speed higher, it goes everything higher, and it comes slowly when the same types of activities are running, and the pulse starts stabilizing. Stability, pulse stability. Also, I've seen there the new principles. Pulse stability. Now, as I'm at 5, my pulse is 64. So, calories already born 106, and speed is 5. Speed is calories born 106. Yes, now still my pulse is stabilized. So in this stability I've seen 64 is my pulse. The speed is still 5 calories I burn so far on 111. Fantastically, I investigated new idea. As the activity rises and the pulse and the calories start rising, and then after same activity running in equal level, and the pulse start equalizing and stability comes normal position like a back, a normal position. Activities goes higher and higher, and the pulse also rises higher and higher. Wow, that's the investigations. Let me go steep one more high. I'm in 6, speed 6, and now that's higher. My calories I spent for 122. Now they've seen 6. What the pulse will be? How the pulse goes? 136. Yes, the speed activities higher the activities goes, the pulse rises up, and still my pulse is rise. And now started stability, coming back to the normal. Even my activities are not stopped. I'm in high speed, like in 6. My speed is 6. Still, my pulse is 983. Now 83 almost started to stabilize in a normal position. My pulse is at the beginning. Now 134 calories I spend. I'm 35 now. And my pulse started down 82. It started to stabilize. Yes. Exactly the principle is the continuous activities goes differently. Now I'm coming back to the normal, yes. Coming back to the very, very normal. What happens? Let's go to the normal. Go very high. What happens is, let's see. My ice vein color so far 140 in case. And where is my pulse? What happened in the pulse? You know, let me see. Yes, 180 now. My pulse, because as we stopped activities also shows higher, because every activities like motion, with motion or motionless activities will demonstrate the fluctuation of the pulse. Wow, that's the great idea. And afterwards, now 92. Now afterwards, after some times, after some minutes or some seconds, the pulse starts stability, goes to the stability and starts maintaining the life. So now my pulse is 88 to 93 raised now. Yes, fantastical ideas. Wow, now I'm going to almost down. Let's go to almost, still more slow. So far, let's see, more slow. Now almost motionless. Almost motionless. And what's happening there? 109 pulse. And so far, 119 pulse. And 147 calories I spent so far. 147. Yes, that's fantastic. Statistics I investigated today. Okay, so now let me stop. Now, in this condition, yes, so far I spent 140 calories in 17.1 minutes, and my distance 0.962, and so far, and now speed is 0. I stopped my motion. And let me see what's going on with my pulse. Yes, 139, because I stopped now, and then still the pulse are in a motion, still motion, and they're coming down 40, 36. Slowly we'll go to the normal position. Now it's still abnormal because the higher that's going on. Okay, yes, and thank you so much, and see you again with another interpretation. Goodbye.